Welcome, developers. In this lesson, we're going to look at how to get data on all objects of a certain type. Since that is a relatively small change compared to what we've done in the previous lessons, namely getting data on a specific object, we're going to do C and C++ in one go. Now, for this, we actually are going to use mostly the same examples as we did from the previous one. So compared to what we did previously, instead of calling RequestDataOnSimObject, we're now going to call a function named RequestDataOnSimObjectByType. And as you'll see, it is mostly the same as RequestDataOnSimObject, but it's now always a once request, so we're just going to get one result, even though it might be a result made up of multiple messages. And we cannot request tagged responses because there is no flags parameter. You must specify a radius around the user's location. And this radius must be specified in meters. I'm sorry, America, it's only metric. A radius of 0 implies that actually only the user or the user's aircraft is in scope. You can specify the type as either all objects or objects of a specific type. The result that you'll get is messages of the type SimConnect receive object data by type, which inherits from the SimConnect receive SimObject data message, but adds no new fields. The DW entry number and DW out of fields in the message are now actually used. And they will tell you how many messages there will be in this single reply and which is the number of the current one. So when they match, you have received the last message. The SimConnect object type is an enumeration that you can use to specify what you want to receive. The simplest to use, of course, is SimConnect SimObjectType all. This will get you the data on all simulated objects within the circle specified. Then we have the type user, and since 2024, the type user aircraft. This just returns the data on the user's aircraft. Of course, if this is all you want, then you can just use a radius of 0. The other one, which is new for 2024, is user avatar. If you are currently walking around the aircraft, then you have an avatar in the system, and the information you receive will be about this avatar. If you're not using the avatar, then there will be no reply. And then, of course, we have user current, which is the easy way of saying, I don't really care whether or not I'm in avatar mode or in the aircraft. I want the user's location. Then we have the different types of movable objects: aircraft, helicopters, hot air balloons, and boats. And you will get the data on that type of vehicles if they are in the circle that you specify. Then we have type ground. Now this would mostly be about ground vehicles, but, and this is something I'm not sure about, it is also possible that you're going to get information about simulated buildings and such. And this is because something we'll see in the next slide. But of course, first we also need to add that since 2024, we quite explicitly have the possibility of asking for the animals in the neighborhood. And of course, it's only about the animals that are explicitly modeled as such. So the scenery developer needs to have or can put an object in there which is just a static or even moving object, animal. But this is about the animated animals, which means that the simulator actually controls their behavior. On the other way around, we not only have the type, but we also have a simulation variable that we can ask about the object that we have that gives us something that is probably meant to be the same as the type. It's called category. It's in the miscellaneous category of simulation variables, but it has a different set of values compared to the type enumeration. The documented values that I have found are airplane, helicopter, boat. They're not ground, but rather ground vehicle, control tower, simple object, and viewer. I have the suspicion that this is because some of the items that you can get returned are actually scenery objects rather than simulated objects, but I'm not sure about this. I have asked about the inconsistency between the SimObjectType enumeration and the values in the category simulation variable. Then there are also a number of values that I got returned when I did a test with it in 2024. I got some simulated values called aircraft pilot, character sim, simple object sim, or static object, and I'm not sure what they are supposed to be or what they signify, although of course you could request the title and then see what kind of things they are. You will find that it might be walking people, it might be different animals, but simple animals, it might be things like a windsock. So let's see what we can do with this. So to start, let's adjust the application that we have in C and make it work with the request data on SimObject by type. Okay, here we are in Visual Studio, and this is the program we had from last time. So let's now change this. So we're going to request data on SimObjectType. So we need to call the other request data function, and that is this one. Now, of course, the parameters, this won't match. We need to remove the last three and instead specify first the radius in meters. Let's take a full kilometer and add a SimConnect SimObjectType and then use the type aircraft. Okay, let's see if this compiles. It does. And of course, now we're going to get a different type of messages in. So I need to go up here, and then what we can do is just simply replace this by the SimConnect receive ID SimObject data by type. And although it is basically the same struct as the SimObject data struct, let's just keep it clean and do it like this. And the rest, even though some parts of it won't be used, I mean, there will be no value in the flags, so has changed and is tagged will always be false. We can just leave that. The hex dump, I think we can let that go. Also, we don't need that. We know it's not going to be tagged. So let's just use the parse untagged and then throw away this. And let's see, parse untagged will print, where is it here? it will print out the information it retrieves. And that should be fine, unless I made any mistakes, but we don't see, we still see one error. Hex dump is not, of course, not referenced. So let's mark that as maybe unused. There we go. So now we can run the program, but of course, at this moment, the simulator is not running yet. So let me start the simulator and then we'll run it. Okay, the simulator is now running. So let's start our program. Restart it, and you see we received data. I can scroll back up, and you see here that the first one we received, that is the user's aircraft, in this case, the Cessna 404. And then if we go down, we find that we have a Microsoft passive aircraft, a Cessna 185 with skis, interesting in the summer. And we have another Microsoft Cessna 185. We have an Asobo M7, another M7. We have a P92, another M7 and M7, an MT7. And a 172 RG retractable gear, another 404. We have a Beach Baron and two other 404s. So you see that there were several aircraft that Flight Simulator put on the airfield. All of them are passive in the sense that they are not controlled by the user. And there is a very large collection of these models available within the simulator that they can use to show you all those simulated aircraft. Okay, that's nice. So let's go back to the slides. So what you've seen is that actually very little needed to be changed. We needed to use a different call, the RequestDataOnSimObjectType. Small typo, I'll correct that. And mostly it works just like RequestDataOnSimObject. But there were some changes. First of all, the change that we need to take into account, even though it is one result, we get multiple messages depending on the query. But those messages together form the single reply. Each message concerns a different sim object. That means that the DW object ID field now can be used to find out what the object ID is of the object shown, which we could use actually to change things on those objects. This we will see later on when we create AI aircraft ourselves and then start to move one around. The fields DW entry number and DW out of are now important, and they were kept track of. And data is always untagged. Now, of course, you know me, so we also can do this in C++. So what did I change there? The same kind of changes, but to make sure that we can use the same way of calling the functions using lambdas, I added an onDone parameter. It will be called when DW entry number is equal to out of, so it's called after the last message has been handled. Your struct can extend from a very simple struct that is in the header files called SimObjectID It just defines a single field called the object ID, and the library will recognize that your struct extends this and then put the object ID from the message in this field. There's also a RequestDataOnSimObjectType method in our library that, instead of a handler for a single message, for a single object, instead has as parameter an unordered map with as keys unsigned long and your struct type as value. Then it will gather all the data in that map and call the handler after the last message has been received. The key is the object ID and the value is your struct. So let's take a look what we can do with that. Okay, so I'm not going to type out all the code because I made a kind of cutesy larger example and I don't want to take up too much of your time, but we'll walk through this. What I did was make a small, very simple class, SimObjectInfo, instead of aircraft.info, and that just contains the title and this category simulation variable that I talked about. Both of them are defined as strings, and I extended the SimObjectID holder, so I want to make use of that functionality that I automatically get the object ID. And then if we go down, we then define the data definition. And when we have the opening, we're going to go here, add the 128 character wide string field for the title and a 32 character wide field for the category. Then we're going to first use RequestDataOnSimObjectType with a handler on our field, and then let it print out the information, the object ID, the title, and the category. And we want to do this for all aircraft within a 10-kilometer radius around us. But then secondly, we're going to use, again, a call, but now we're going to use a data map handler. And I prepared a method for that here. So we have the the function handling an unordered map for an unsigned long and our SimObjectInfo. And what it does, because it now has in one go all of the objects. So let's just do some summarization. So it's going to collect what categories do we have, what different titles do we get per category, and it'll do some object counts. So if it gets an airplane, it counts that, a helicopter, boat, ground vehicle, an animal, and otherwise it's some unknown thing. And it collects all the titles per category. And then after it has done the go through to the map, it will then print out the information that we have. And also give the number and the unknown categories. So then it will call that, and then of course it's need to handle those messages. So let's see what this does. Okay. So we start here with the list of all aircraft. Again, here you see the 404s and the C185 with skis. All of them, we see the object ID has been neatly inserted into our record and category airplane. Then let's go down. We received data for 669 simulated objects. There was only one title in this category, and that was not given. So an empty title actually for aircraft pilot. So this is probably something for the avatar. I'm not sure. Then in category airplane, we had these aircraft, and I can see that there are actually also some Airbus 320s and 737-700s in the neighborhood. Then going down, we have a number of animals. So there are a few bulls here, female variation. So a few cows, a few horses, and a few sheep. Then we have a number of boats and one person, a few ground vehicles. We have some procedural characters. So those are characters, those are probably people that are part of the scenery and have a very simple script for their movements. So they're probably doing things like walking around or just waving or wiggling their hands a bit. Maybe it's one of those ground personnel people in front of your aircraft waiting for you to ask for pushback, something like that. Then there are some tow and pilot things that you can play with. Oh, passengers and pilots just. That's simple object sims. Okay, interesting. Hadn't seen those before. Then we have glider trailers, the gliders, marshaller sticks, smoke. There's a windmill, there's a windsock. So yeah, a lot of different objects. Actually, almost 250 animals. Interesting. So this is all the information you can ask, and you could get more detailed information or actually move them around if you want. But then first you need to know that they're there. So the get SimObject by type allows you to do just that, to find out what is in my neighborhood. So, well, let's continue with the slides. We now have a way of finding out what other objects are simulated near us. We can do repeating requests by repeating the request, but we don't have a SimConnect period-like parameter. So we cannot say, do me every 5 minutes a fresh list. You have to write something for that. Of course, if you have multiple threading possibilities, you can use a separate thread for that. Some improvements I think would be nice. I think Asobo needs to work on the SimObjectType because there are lots more objects than you can specify. And it would be nice to combine types in a single request. I also already have some ideas how you can do that in the C++ library. So if you're tracking those sources, you'll find something for that in there. And the category simulation variable has different types than we find in SimObjectType. So, well, at the very least, I hope they're going to update the documentation on that. So that was it for this one. See you next time. What will we do? Well, I said I wanted to go on with set data, but I don't want to do that on myself. I can warp the aircraft around, but I don't think that is too interesting. Let's instead first do a bit of AI creation. We're not going to do a full walkthrough of all the different forms of AIs, but just enough of it to create static aircraft, which also means we need to find out what type of static aircraft we can ask for. And there is a call for that to enumerate the titles and the liveries for those titles. So we'll do that as well. And then let's do a record and playback. I think that's a nice thing to do. We're just going to make a recorder. We can specify on the command line or in some way how many seconds, and it will record our movements. And then we can go back and go to a different parking position and make sure that we can look at where we were and then replay that and have our previous aircraft show up and go through its paces. So thank you for your attention. As always, I do this for the subs and likes. So if you like this, give me one of those, and I'll see you in the next one.